Oi, what's this? Oh. Hi, my name is Muhammad Afan bin Afandi. My matrix number is 20226199496. Today, I'm gonna explain to you guys one of the subtopic in redox reaction, which is the definition of redox reaction and the type. Okay, the type of redox reaction. Okay, firstly, before we start our lesson, we need to know the definition of redox reaction. What does it mean by redox? You need to remember two words, okay? Two words. The first word is what? Reduction. Okay? Reduction. Reduction. Simple. There's red and ox. Red is for reduction and ox is for oxidation. What does that mean by reduction and oxidation? Simple. Oxidation means when a reagent gain electron and increase the oxidation number, you're gonna oxidation reaction gonna take place. What does it mean? Let me show you later. Okay, gain of electron and increase in oxidation number. For reduction, meanwhile for the reduction, loss when a reactant loss in electron and decrease the number of oxidation number, we're gonna do a reduction reaction. Okay, loss of electron increasing. Okay, before I move on, I will give you one example. Okay, one example, just easy example. Okay, for both of this kind of reaction. Firstly, I'm going to give you the reaction for oxidation reaction. Okay, which is zinc sulfur plus zinc sulfur, so it becomes zinc plus 2 electron. Okay, this is what we call a half reaction for oxidation reaction. Okay, what does it mean by this half reaction? Okay, whenever as I said before, oxidation means the reactant must gain electron. Okay, see, the zinc firstly doesn't have any electron because it's in the elemental form. What does happen? It becomes zinc in aqueous state and it also have 2 electron. Okay, so based on this reaction, we know that zinc already get 2 electron. So what we call of this reaction, of this half reaction? Correct, oxidation reaction. Good job. Next, we move to reduction reaction. The will be simple. Aqueous form plus 2 electron will be okay. For the reduction reaction, okay, the cuprum firstly it has electron which is 2, same goes with zinc. Okay, but at the end of reaction it become cuprum in elemental form which is solid. Okay, that's what we call reduction reaction. Because of why? Because cuprum lost its electron and cuprum oxidation number decrease. Okay, next we move on into the type of redox. The first one we have electron transfer. Okay, for the electron transfer, even the reactant lost electron, that means the oxidation reaction take place. Okay, if the react, okay, I'm gonna give you an example, pretty simple. Okay, this is a reactant. Okay, reactant lost electron. Okay, lost electron by substance. What does it mean? That means this reactant is gonna do oxidation reaction. Meanwhile, for reduction, it's gonna gain, okay, it's gonna gain electron, okay, electron by a substance. That means reduction reaction already happened into this substance, okay. And for oxidation reaction, okay, for the oxidation reaction, the number of oxidation number for oxidation reaction, wow, pretty confusing, right? Okay, let me repeat it again. Oxidation reaction, oxidation reaction for the reagent oxidation number is gonna be increased if when the reaction, when oxidation reaction happen, okay. Let me repeat it again, okay. The reagent oxidation number is gonna increase when oxidation reaction happen, okay. For the reduction, it's gonna be the antonyms. It's gonna decrease in oxidation number. Okay, let me give you an example, a simple one. Sorry, we have magnesium and oxygen. It's gonna be magnesium oxide. Okay, from this, can you see it? Okay, you see it. From this reaction, we know that magnesium gain oxygen. So, from this reaction, we know that magnesium is oxidized. By who? By oxygen itself. Oxygen here is what we call oxidizing oxidizing agent. Meanwhile, for the magnesium, it's gonna be reducing agent. Okay, magnesium is oxidized. That's why the product is become magnesium oxide, because the magnesium is oxidized. Okay, oxidized. And the magnesium gonna donate its electron, okay, gonna donate its electron to oxygen, okay, donate electron to oxygen and cause oxygen to be reduced. Therefore, for the oxygen is reduced, okay, and act as an oxidizing agent, and also it accept the magnesium, it accept the electron from magnesium and cause magnesium to be oxidized. Okay, we move into our next type of redox, which is, for me, the easy one, which is the oxygen transfer. What is the meaning of oxygen transfer? If a reagent, which is, I will take iron 3, okay, I will take iron 3 carbonate, dioxide, okay, plus carbon monoxide. It's going to be ferrum and carbon monoxide. Right. Yes. Okay. Okay. From this reaction, we know that ferrum loss. Ferrum loss what? Ferrum loss is oxygen. Okay. What does it mean? This means that ferrum 3. This means by iron 3 oxide is reduced by who? By carbon monoxide. Okay. In this reaction, carbon monoxide is gonna be the oxidation reagent, oxidation agent, and carbon monoxide is gonna be reducing agent. Why? Meanwhile, for ferrum 3, iron 3 oxide is gonna be the reducing agent. Okay. If let's say the reagent, okay, the reagent which is I'm gonna take this carbon monoxide. If the reagent gain oxygen, oxidation reaction will take place. But if the reagent lost oxygen, reduction reaction will take place. So for the carbon monoxide, is it gain oxygen or loss in oxygen? Correct. Carbon monoxide gain oxygen. Okay. That means carbon monoxide is having oxidation reaction. Okay. We move on into our last type of reaction. Okay. Which is the hydrogen transfer. Okay, you need to remember, for the hydrogen transfer, if the reagent loss of hydrogen, oxidation reaction gonna take place. Okay, if the reagent gain of hydrogen, so it's gonna be reduction reaction. Okay, I guess let me show you a simple example. Okay, we have CH3, CH2, OH, become CH3, CH2. Right? Okay, for as you can see from this reaction, okay, this compound loss of hydrogen. What does it mean? As I said before, loss of hydrogen, oxidation reaction is going to take place. So this compound will do oxidation reaction. Okay, this compound gonna do oxidation reaction and become this product. Okay, there's a lot more I want to explain to you about this interesting chapter, but that's all from now because time doesn't enough. So I guess that's all from me. Thank you very much for spending your time with me. See you next time.